Now let's explore the likelihood of a key piece of Bayes' theorem. The likelihood answers this question. How likely is the data I observed assuming a particular belief is true? In Bayes' theorem, it plays the role of connecting the prior, what we believe, with the data, what we see. It's not the same as probability of the hypothesis. It's really the probability of the data given the hypothesis. So let's break this down. Now let's, with an example, clarify the difference between probability and likelihood. So probability usually refers to the chance of observing data assuming a known model or hypothesis. And the likelihood is about assuming different models based on observed data. In Bayesian statistics, the likelihood acts as a weighted mechanism. It tells us which beliefs are more supported by the data. Now imagine if we flip a coin 10 times and get 7 heads. We're trying to figure out what the true probability of heads might be, but the different hypotheses are possible. If it's a fair coin, 50%, or maybe it favors heads, maybe 70% to 90%. Now the likelihood tells us which of these hypotheses make the observed outcome, which is 7 heads, most likely. It helps us to update our belief based on what we saw. Now, the likelihood is what shapes the posterior. If your data strongly supports a hypothesis, it gets more weight. If your data doesn't support the hypothesis, it gets downweighted. The posterior is the result of this balancing act between your prior beliefs and what the data tells you. As you get more data, the likelihood plays a bigger role, and your beliefs become increasingly data-driven. So now that we've talked about the priors and likelihoods, we'll be ready to bring it all together. Now, in the next video, I'll explore the posterior and what it represents. Now, I'll also cover how to interpret it and why it is the foundation of Bayesian decision making. Okay, see you in the next video.